morning to respected Principal Dr. Poonam Chauhan Madam, eminent keynote speaker, beloved lecturers, and dear students. A very warm welcome to all the participants. On behalf of KBS and Natraj College, I, Khushbu Desai, Assistant Professor of Department of Chemistry, heartily welcome you all for today's webinar on Symmetry and Group Theory in Chemistry and its Applications. The basic objective of this webinar is to provide expertise knowledge about the subject. I, being honored to tell you that more than 300 participants from the various colleges have registered and participating in this webinar. Thank you all for taking time out and being here for today's webinar. I would like to request respected Principal Dr. Poonam Chauhan to say few words.
Thank you, Khushbu. Myself, Dr. Poonam Chauhan from KBS Commerce and Natraj Professional Sciences College. Welcome you all for today's webinar. I especially thank Dr. Paresh Patel for being associated with us for such a wonderful session and giving an ignition to the students by his vast knowledge and sharing his experience with us. He has been with us from last 4 sessions, and I hope in the future too, sir will be doing the same and giving the benefits to the students. I also welcome and thank all the participants and staff who has been part of this webinar session. And I hope this session will also be as useful as the previous one was. And I hope we will continue this in future too. So once again, I welcome you all for this webinar and I hope you all the best. Thank you.
Thank you, madam. Thank you very much. Now, we'll turn the time over to introduce today's keynote speaker. It's a great honor and matter of pride to introduce our eminent keynote speaker, Dr. Paresh S. Patel. He has been working at the Post-Graduation Department of Chemistry, Veer Narmad South Gujarat University, Surat, and presently holds the post of professor. He received his MSc and PhD in the subject of organic chemistry. Sir has 24-year teaching experience in the field of chemistry and he is specialized in organic chemistry, reaction mechanism, pericyclic reactions, photochemistry, natural product, rearrangement, and molecular symmetry, and many more subjects. His research interests include synthetic organic chemistry, dyes, drugs, and polymer. He has published about 51 research papers in various reputed national and international journals. Recently, he is supervising 6 research scholars, while 7 candidates have completed their PhD research under his guidance. He has served as investigator of a major research project funded by the University Grants Commission, India. Sir is serving as a life member of Indian Chemical Society and Indian Council of Chemists, and he is also serving as member of Boards of Studies, School of Science at PP Savani University, Surat. Sir also has delivered many invited talk expert lectures at various universities in Gujarat state. He served as a resource person in one-day workshop under Odisha KCG Education Department, Government of Gujarat. Dr. Patel has also been judged in national, international, and state level conferences and seminars. Thank you very much, sir, being with us and providing your valuable time with us. Thank you, sir. I request respected Dr. Paresh Patel, sir, to address the participants.
Thank you, Kusuma Madam. Respected principals of the KBS Commerce and Natraj Professional Science College, Vapi, respected teachers, coordinator of this webinar series, Khushbu Ben, and dear participants. First, I am very thankful to the principals of KBS Commerce and Natraj Professional Science College Vapi, to provide me the opportunity to give a platform to share my views to the uh, students of our V Normal South Gujarat University. So once again, I am very, very thankful to Madam. Uh, Thank you, Kusmo Madam, for nice introductions. So today we are going for the one topic in paper number one, and the name of our unit is the molecular symmetry and group theory in chemistry and its applications. So before starting our topic, I would like to say something introductory part of our molecular symmetry. uh, we know that the correspondence of a parts of a figure with reference to plane, line, or point of a symmetry. Thus, next slide, please. Khushbu madam, please next slide. Thus, circle is a symmetrical about any diameter. The term symmetry has become synonymous to the beauty because the nature has made most of creation symmetrical, as for example the sun, planets, animals, and plants. Scientifically speaking, an object is said to be symmetrical if it can take up more than one equivalent orientation. Uh, if we take examples of the hydrogen, so in hydrogen molecule in orientation we can rotate about 180, that is through the imaginary axis, to get the equivalent orientation position. So that is known as molecular symmetry in hydrogen molecules. So next slide, please. So symmetry is in all around us. This is very beautiful butterfly, Taj Mahal, as well as in chemistry also. So next slide, please. Okay, this is the two-fold axis of symmetry in Taj Mahal as well as in Eiffel Towers. Next, please. So symmetry is an object has two or more equal sides when split in half of the similar pieces. Next one. Okay, we already discussed about this. Next. Now, symmetry elements and the symmetry operations, these two terms are the most important in this symmetry. We know that plane, line, or point. These are known as a symmetry elements, and the process is carried out on either plane, line, or point to get the equivalent orientation position is known as molecular symmetry operation. So, what is symmetry operation? The process is carried out on a molecule to get the equivalent orientation position is known as symmetry operations. The next one is the symmetry elements, plane, line, or point. These are known as symmetry elements, and the process is carried out on plane, line, or point to get the equivalent orientation position. That is known as symmetry operations. Now, symmetry elements, identity, proper axis of rotation, mirror planes, center of symmetry, improper axis of rotation, and their related the symmetry operations are the most important in the molecular symmetry. Next, please. Now, first symmetry element is the identity. We know that all molecules have an identity symmetry elements, and if we operate identity symmetry operation on any molecule, so the entire molecule will be unchanged. So there is no change in the position of the molecules. Each and every molecule consists identity symmetry elements. Okay, so dear students, uh, each and every molecule consists symmetry elements, and if we operate identity symmetry operation on molecule, there is no change in the position of the molecules. Yes. Second one is proper axis of rotation. Okay, so proper axis of rotation, symmetry element can be represented as Cn, and symmetry operations can be represented as a Cnk. Okay, n is the order of axis, and k is equal to numbers of time that symmetry operations. Okay, now in case of proper axis of rotation, proper axis of rotation can be represented by Cnk. K is equal to order of axis, n is equal to order of axis. Okay, if we rotate, okay, now what is proper axis of symmetry? We have to image a image a axis, and with the help of that axis we have to rotate the molecule to get the equivalent orientation position. It means we can find out the n is equal to theta is equal to 180. So in that case theta is equal to n is equal to 2. If we rotate the molecule around 120, so n is equal to 3. If we rotate molecule around 90 degrees centigrade to give n is equal to 4, and if we rotate around 60 to give n is equal to 6. Okay, so what is proper axis of symmetry? We have to image a axis, and with the help of that imaginary axis uh, we can get a equivalent orientation position of the molecule. So that is known as proper axis of symmetry. Okay, if we rotate a molecule around 180, so in that case n is equal to 2. It means symmetry element is C2. If we rotate molecule around 120, so in that case n is equal to 3. It means symmetry element is C3. Okay, now what about symmetry operation? Symmetry operations can be represented by C and K. N is equal to order of axis, and K represents numbers of times symmetry operations. Okay, next please. Okay, in case of water molecule, okay, this one is the imaginary axis. Okay, in case of the imaginary axis, if we rotate water molecule along the imaginary axis around 180 to get the equivalent orientation position. So in that case, we can get the equivalent orientation position by rotating these molecules around 180. It means n is equal to 180 by 2. It means n is equal to 2. 360 divided by 180 is equal to 2. So n is equal to order of axis. Order of axis is equal to 360 by 2 is equal to, 360 divided by 180 is equal to 2. So order of axis in case of the water molecule is equal to 2. In case of ammonia molecule, we know that uh, the shape of ammonia molecule is a pyramidal. If we rotate these molecules along the imaginary axis around 120 to get the equivalent orientation position, it means n is equal to 3. Why n is equal to 3? N is equal to 360 divided by 3. It means 120. So in case of ammonia molecule, order of axis is equal to 3. So symmetry elements for ammonia molecule is equal to C3 plus or C3 minus. Why? The clockwise rotation as well as anti-clockwise rotation can be possible. Okay, in case of ammonia molecule, if we rotate these molecules along the imaginary axis around 120 to get the equivalent orientation position. Dear students, in case of ammonia molecule, the shape of ammonia molecule is pyramidal, and this one is the imaginary axis, and with the help of this imaginary axis we can rotate the molecules along this axis around 120 to get the equivalent orientation position. So n is equal to 360 divided by 2 3 360 divided by 120 is equal to 3. It means order of axis for ammonia molecule is equal to 3. Am I right? In case of water molecule, if we rotate these water molecules along the imaginary axis around 180 to get the equivalent orientation position, વોટર મોલેક્યુલની અંદર આપણે ઇમેજ કરવાનું છે, અને આ ઇમેજનરી એક્સિસથી આપણે 180 રોટેટ કરીએ તો આપણને એના જેવો જ મોલેક્યુલ મળશે. સો n is equal to 360 divided by 180 is equal to 2. It means order of axis for water molecule is equal to 2. So symmetry element is C2. In case of ammonia molecule, if you rotate these molecules along the imaginary axis around 120 to get the equivalent orientation position. So n is equal to 360 divided by 120. is equal to 3. It means order of axis for ammonia molecule is equal to 3. So symmetry elements can be represented as a C3 plus, C3 minus. Okay. If we rotate these molecules along the imaginary axis around clockwise to get the equivalent orientation position, so that symmetry elements can be represented as C3 plus. And if we rotate these molecules along the imaginary axis around uh, about anti-clockwise, that is known as C3 minus symmetry elements. Okay. Now, what will happen if we operate symmetry operation C3 plus? So, to change the position of hydrogen 1, hydrogen 2, and hydrogen 3. So, that symmetry operation can be represented as C3 plus or C3 1. Okay. Another 120 rotation, that is known as C3 2. Next, please. Now, this is two-fold axis of rotation. We already discussed that is in water molecules. This is the imaginary axis, and with the help of this imaginary axis, if you rotate these molecules along this imaginary axis around 180 to get the equivalent orientation positions. Now, next one is rotation for a trigonal Polonin molecule. As for example, Bf3 molecule, BCl3 molecule, the shape of that molecule is a planar structure. Now, if we rotate these molecules along the main principal axis around 120 to get the equivalent orientation position, in case of the Bf3 molecule, main principal axis, okay, so imaginary axis is C3. Why C3? If we rotate these molecules along the axis around 120, so order of axis n is equal to 360 by 120 is equal to 3. So order of axis for Bf3 molecule is also 3. Now, symmetry elements can be represented as C3 plus and C3 minus. Now, in case of this trigonal planar molecule, 3 C2s are perpendicular to the main principal axis C3. In case of 3 C2s are perpendicular to the main C3. And if we rotate this molecule along that axis around 120 to get the equivalent orientation position. Dear students, ટ્રાઇકોનલ પ્લેનર મોલેક્યુલ્સની અંદર આપણે જોઈએ તો એક ઇમેજનરી એક્સિસ છે, એને મદદથી આપણે 120 રોટેટ કરશું તો આપણને એના જેવો જ મોલેક્યુલ મળશે. અને આ જ મોલેક્યુલમાં આપણે બોરોન ક્લોરિન બોન્ડને 180 રોટેટ કરીશું તો આપણને એના જેવો જ મોલેક્યુલ મળશે, તો એને C2 કહીશું. તો આવી C2 આપણને 3 C2 મળશે. Okay, so dear students, Bf3 or BCl3 molecule consists two types of the rotational axis. One is C3 plus C3 minus, and second one is 3 C2s. So C3 is perpendicular to 3 C2s in case of trigonal planar molecules. Now, let me know about which one is the main principal axis. So according to the rules of the molecular symmetry, if the order of that axis is higher, so we have to consider that axis as a main principal axis. Now, in case of C3 and C2, C3 has more order than C2, so we have to consider C3 is a main principal axis. So according to rule, higher order proceed first as a main principal axis. But in case of order of axis are the same, then we have to think about the main principal axis. So in that case, if order of axis is passes to the numbers of the atoms, that can be considered as a main principal axis. Okay, so dear students, if order of axis are the same, then we have to take the main principal axis in such a way that that axis passes to the numbers of atoms that can be considered as the main principal axis. Dear students, આપણે જે મેઇન પ્રિન્સિપલ એક્સિસ છે એનો ઓર્ડર સૌથી વધારે હોય એને મુખ્ય પરિભ્રમણ અક્ષ તરીકે આપણે લઈએ છીએ, પણ જેની પાસે સરખો જ ઓર્ડર હોય, એઝ ફોર એક્ઝામ્પલ એલિન મોલેક્યુલ પાસે 3 C2s છે, તો એવા કેસની અંદર જે પ્રિન્સિપલ જે એક્સિસ વધારે એટમમાંથી પાસ થતી હોય એને મુખ્ય પરિભ્રમણ એક્સ તરીકે કન્સિડર કરવાની હોય છે. સો નેક્સ્ટ વન પ્લીઝ. Now this is the C4 axis of rotation in cyclobutane molecules. In case of the cyclobutane molecule, this is the imaginary axis, and if we rotate these molecules along this axis around 90 to get the equivalent orientation position. So this above the symmetry, order of axis n is equal to 360 by 90 is equal to 4. It means order of axis is equal to 4. And symmetry operations can be represented as C41, C42, C43, and C44. Okay, next please. In case of the cyclopentadiene system, if we rotate these molecules along the imaginary axis around 72 to get the equivalent orientation position. So here n is equal to 360 divided by 72 is equal to 5. It means order of axis for cyclopentadiene is equal to 5. 360 divided by 72 is equal to 5. And symmetry operations can be represented as C51, C52, C53, C54, and C55. Now in case of the cyclopentadiene system, 5 C2s are also present, and all the five C2s are perpendicular to the main principal axis C5. So in case of cyclopentadiene, one main principal axis is C5. Why? The order of this axis is higher than the 5 C2s. Okay, so in case of the cyclopentadiene, main principal axis is C5, and 5 C2s are perpendicular to the main principal axis. Okay, symmetry operations can be represented as C51, C52, C53, and C54, C55. Now in the next one, in case of benzene ring, okay, we know that main principal axis can be represented as C6. Why C6? If we rotate these molecules along the imaginary axis around 60 to get the equivalent orientation position. So that's why order of axis in case of the benzene molecule is equal to 360 by 60 is equal to 6. It means order of axis in case of in case of the benzene molecule is equal to 6. So symmetry operations can be represented as C61, C62, C63, C64, and C65 and C66. Okay. Now, in case of the benzene molecule, 6 C2s are perpendicular to the main principal axis. So in that case, if we rotate these benzene molecules around 180 to get the equivalent orientation position. So these are known as a twofold axis of symmetry. So in case of the benzene molecule, main principal axis is C6, and C6 is perpendicular to the 6 C2s. Next one please. This is the 3-4 axis in rotation. We already discussed in case of the Bf3 molecules. In case of the Bf3 molecules, main principal axis is C3. If you rotate these molecules along the main principal axis around 120 to get the equivalent orientation position, and 3 C2s are perpendicular to the main principal axis. Now in this case, C3 is the main principal axis. According to rule, higher order proceed the first as a main principal axis. So C3 can be considered as a main principal axis, and 3 C2s are perpendicular to the main principal axis. Next one please. We already discussed about this C3 and C2 axis in Bf3 molecules. Main principal axis is C3, and three C2s are perpendicular to the main principal axis. Next one, please. Now, these are the different rotational axes of symmetry. In case of first one is Bf3 molecules. So main principal axis is C3. In case of NiCN4 minus 2 complex, if you rotate this molecule along the main principal axis or imaginary axis around 90 to get the equivalent orientation position. So in that case, C4 is the main principal axis. In case of the benzene molecule, benzene consists main principal axis is C6, and if you rotate these molecules along the imaginary axis around 60 to get the equivalent orientation position. So how to find out the numbers order of axis? N is equal to 360 by theta. Okay, in case of benzene molecule, 360 by 60 is equal to 6. So order of axis in case of the benzene molecule is equal to 6. So symmetry elements can be represented as C6 and C61, C62, C63, C64, C65, and C66. These are the symmetry operations. Next molecule is the Bf3 molecule. The shape of the Bf3 molecule is planar structures. So if we image a main principal axis as a imaginary axis, and if we rotate these molecules around 120 to get the equivalent orientation position. So order of axis in case of the Bf3 molecule is equal to 120, and three C2s are perpendicular to the main principal axis. Now in case of the NiCN4, that is in case of the NiCN4 minus 2 complex, four C2s are perpendicular to the main principal axis C4. So if we rotate these molecules around 120, 180 to get the equivalent orientation position. In case of the benzene, main principal axis is C6 and 6 C2s are perpendicular to the main principal axis. Next one, please. This is C3 rotation Bf3 molecules. If rotate these molecules along the main principal axis to get the equivalent orientation 1, 2, 3, and 4. Next one, please. This is the proper rotation in case of the PTCl4 minus 2 complex. So in case of the PTCl4 minus 2 complex, the main principal axis is C4. Why C4? If you rotate these molecules along this axis around 90 to get the equivalent orientation position, and four C2s are perpendicular to the main principal axis. Why C2? If you rotate this molecule along that axis around 180 to get the equivalent orientation position. Next one, please. So these are the two C2s. Next one. This is the second C2s. Next one. Yes, these are the another two C2s, and that C2s are perpendicular to the main principal axis. Okay, so in case of the PTCl4, yes, please. In case of PTCl4 minus complex, main principal axis is C4, and four C2s are perpendicular to the main principal axis. So symmetry elements can be represented in case of PTCl4 minus 2 complex is C4 plus, C4 minus, and C4 is perpendicular to 4 C2s. Next one. Now this is in case of FeCO5. FeCO5. This is metal carbonyl. The shape of this metal carbonyl, FeCO5, iron pentacarbonyl, is trigonal bipyramid. Okay, so if we rotate this molecule along the main principal axis around 120 to get the equivalent orientation position, it means n is equal to 360 divided by 120 is equal to 3. It means this imaginary axis can be represented as C3. So C3 is the main principal axis. Why? In case of PF5 molecule, if we rotate these molecules around 180 to get the equivalent orientation position. So in case of the FeCO5, main principal axis is C3 and three C2s are perpendicular to the main principal axis. So symmetry elements can be represented as C3 plus, C3 minus, and C3 is perpendicular to 3 C2s. Next one. In case of the now, so third symmetry element is plane of symmetry. We already discussed about the first symmetry element is the identity. Second symmetry elements and the related symmetry operation. This is the proper rotation and proper axis of rotation. And third one is plane of symmetry. Plane of symmetry can be represented as a sigma. Now, what is plane of symmetry? We have to image a plane or mirror, and with the help of plane or mirror which can bisect the molecule, so one part of a molecule is the mirror image of the another part of the molecule. So repeat again, dear students, here we have to image a plane, and with the help of this plane one part of the molecule can be considered as another part of the molecules. So that type of the symmetry can be represented as a plane of symmetry. Okay, dear students, અહીંયા આપણે મિરર ની કલ્પના કરવાની છે અને આ મિરરની કલ્પના કરવાથી મોલેક્યુલનો એક તરફનો ભાગ બીજા તરફનો મિરર ઇમેજ બને તો આ પ્રકારની સિમેટ્રીને આપણે કહીશું પ્લેન ઓફ સિમેટ્રી. Now, plane of symmetry can be classified into three categories. First one is mirror containing principal axis of rotation. Okay, it means if plane is parallel to the main principal axis is known as vertical plane of symmetry. Now, what is vertical plane of symmetry? If plane is parallel to main principal axis, so this type of the plane of symmetry can be recognized as vertical plane of symmetry. Second type of the plane of symmetry can be recognized as a horizontal plane of symmetry. If plane is perpendicular to the main principal axis, so that type of the plane of symmetry can be recognized as a horizontal plane of symmetry. And third one is diagonal or dihedral plane of symmetry. If plane of symmetry, main principal axis and C2, this above the plane can bisect the main principal axis and C2 in such a way that one part is the mirror image of the another part of the molecule. So this type of the symmetry can be recognized as a diagonal or dihedral plane of symmetry, and which is symbolized by sigma d. Okay, vertical plane of symmetry. What is vertical plane of symmetry? If plane is parallel to main principal axis, so that type of this symmetry can be recognized as a vertical plane of symmetry, and that symmetry elements as well as symmetry operations can be represented as sigma v. Second one is if plane is perpendicular to the main principal axis, so that type of the plane of symmetry can be recognized as a horizontal plane of symmetry, and horizontal plane of symmetry can be symbolized by sigma h and sigma d, which can bisect the molecule in such a way that one part is the mirror image of the another one part of the molecule to the another part of the molecule, as well as which can bisect the C2 main principal axis and C2, and which can be symbolized by sigma d. Next one, please. First one is vertical plane of symmetry. Now, in case of the water molecule, C2 is the imaginary axis. Okay, or we can say in case of the water molecule, two planes are present and both these planes are parallel to main principal axis. So water molecule consists two vertical planes. In this case, main principal axis is parallel to main principal axis. Two planes are parallel to main principal axis. So in case of the water molecule, sigma xy and sigma yz, two planes are present in the water molecules. Why these are known as a vertical planes? Because both these planes are parallel to main principal axis. So first symmetry element is sigma Vx and sigma Vyz. Next one, please. In case of the ammonia molecules, the shape of the ammonia molecule is pyramidal, and in case of the ammonia molecule, all the three planes that can be symbolized by sigma Va, sigma Vb, sigma Vc, or sigma V1, sigma V2, sigma V3, and all the three planes are parallel to main principal axis. So this type of the symmetry can be recognized as vertical plane of symmetry. Next one, please. Second type of the plane of symmetry is horizontal plane of symmetry, and this type of the symmetry can be recognized as sigma H. Now, in this case, main principal axis is perpendicular to the main principal axis, so this type of the symmetry can be recognized as horizontal plane of symmetry, and this type of the symmetry can be symbolized by sigma H. Next one. This is Pf5 molecule. In this Pf5 molecules, the main principal axis is perpendicular to the uh, plane is perpendicular to main principal axis. So this above the plane of symmetry can be recognized as horizontal plane of symmetry. Dear students, uh, the shape of the PF5 molecule is trigonal bipyramid. It means we have to image a plane in such a way that uh, that plane is perpendicular to the main principal axis. So PF5 molecule consists one horizontal plane. Okay, next one, please. Now, third type of the plane of symmetry is diagonal plane of symmetry. And this diagonal plane of symmetry can be symbolized by sigma d. Now, what is diagonal plane of symmetry? This type of the plane which can bisect the main principal axis as well as C2 in such a way that one part of the molecule is the mirror image of the another part of the molecules. So this type of the plane of symmetry can be recognized as diagonal plane of symmetry. As for example, alene molecule. In alene molecule, we already discussed that alene molecule consists three C2s. Now, which one is the main principal axis? The order of axis of all the three C2s are the same. Then C2 passes to numbers of the maximum atom that can be considered as a main principal axis. Now, this plane can bisect the main principal axis and other C2 in such a way that one part is the mirror image of the another part of the molecule. So, this above the symmetry can be recognized as a diagonal plane of symmetry. Next one, please. Yes. In case of the benzene, in case of the water molecule, in case of uh, in all the three cases, water molecule consists sigma V, benzene molecule consists sigma H. Next one, please. Now, fourth symmetry element is center of symmetry. Center of symmetry can be recognized by can be symbolized by small I. Now, this is the imaginary point. Okay, in case of the proper axis of rotation, we have to image a axis. In case of plane of symmetry, we have to image a plane. Now, in case of the center of symmetry or point of a symmetry, we have to image a point. And in this is an imaginary point in center of molecule through which the reflection of each atom can be carried out to result in its coincidence with the equivalent atom. In case of center of symmetry, we have to image a point, and with the help of this point we can inversify each atom of the molecule, or which can inversify the each atom of the molecule. So this above the symmetry can be recognized as center of symmetry. Next one, please. center of inversion. In case of uh, point, imaginary point, we can inversify each atom of the molecule through this point, is known as center of inversion. Next one, please. Now, this is the trans-dichloroethylene and benzene. In case of the benzene, this is the imaginary point, and with the help of this point, we can inversify each atom of the molecule. In case of the trans-dichloroethylene, the center of symmetry is also present in these molecules. Next one, please. Now, last symmetry element is improper axis of rotation, improper axis of symmetry, or rotational reflection axis of symmetry. And this above the symmetry element can be symbolized by Sn. Sn is the symmetry element, and symmetry operations can be represented as Snk. N is equal to order of axis, and k is equal to numbers of time that symmetry operation. Now, this is the axis. This is an axis passes through the molecule on which the molecule has to rotate about 2 pi by n angle and then reflected on a plane perpendicular to the rotational axis to attain equivalent orientation. This is of improper rotation and can be represented by Sn. Okay. Now, what is proper axis of symmetry or rotation reflection axis of symmetry? Dear students, we have to image a rotational axis and we have to rotate our molecule along the imaginary axis, and then reflection through horizontal plane. Horizontal plane, it means that plane should be the perpendicular to the main principal axis to get the equivalent orientation position. So this above the symmetry can be recognized as improper axis of symmetry or rotation reflection axis of symmetry. Next one, please. Now, improper rotation in a tetrahedral structures. Okay, so in case of that one, now first molecule, if you rotate these molecules along the rotational axis and then reflection to give the uh, rotation and reflection axis of symmetry, or we can say improper axis of symmetry. Next one, please. These are the two S1 and S2 improper rotation. Next one, please. So after all, we got the 5 symmetry elements and that related symmetry operations. So we already discussed the first symmetry element is identity. And if we operate identity symmetry operation on any molecule, we have to do nothing. Second symmetry operations can be represented as proper axis or axis of symmetry. Okay, in that case, we have to image a axis, and with the help of that axis, we have to rotate this molecule along that axis to give the equivalent orientation position. So that can be symbolized by Cn. And if you operate symmetry operations through that axis, that can be represented by Cnk. Okay, so dear students, first symmetry element is identity, second symmetry element is proper axis of rotation, or we can say axis of symmetry. Now third one is mirror image, mirror plane or plane of symmetry, can be recognized as a sigma, and reflection symmetry operation can be represented about reflection about the plane. Mirror plane or plane of symmetry can be classified into 3 categories. First one is vertical plane of symmetry. In that case, if plane is parallel to main principal axis, so that type of the plane of symmetry can be recognized as vertical plane of symmetry. If plane is perpendicular to the main principal axis, so that type of the plane of symmetry can be recognized as a horizontal plane of symmetry. And diagonal or dihedral plane of symmetry, which can bisect the main principal axis and situ in such a way that one part of the molecule is a mirror image of the another part of the molecule. Fourth symmetry element is a center of symmetry or inversion of symmetry. We have to image a point, and with the help of that point, we can inversify each atom of the molecule. And last one is rotational reflection axis of symmetry or improper axis of symmetry. So in that case, we have to rotate molecule along the imaginary axis and then reflection to get the equivalent orientation position. So dear students, these are the symmetry elements and their related symmetry operations. Now we are going for the another general introduction part of our molecular symmetry is point group. Next one please. Hello. Yes. Dear students, this is the most important uh, title in molecular symmetry is the point group. Uh, Now, point group is nothing but the collection of different symmetry elements or different symmetry elements and the related symmetry operation reached to point is known as point group. According to the Soin-Fleisch methods. So we have to follow this chart, and with the help of this chart, we can assign a point group to the any molecule. So first of all, we have to make a questions: is a molecule linear or non-linear? Okay, if it is linear, then we have to assign c infinite v or d infinite s point group. Then we have to make a questions that uh, molecule consists any multi higher order axis, multiple higher order axis of symmetry. Now what is a multiple meaning of multiple? Multiple minimum multiple is 3, and higher order, so C3 can be considered as a minimum criteria to be a higher order of axis. Okay, if the molecule consists minimum higher order of axis, then TD or OH point group may be present. Okay, then we have to make a questions that molecule consists any symmetry or uh, any proper axis of rotation. If no, then C1, CS or CI point group may be present. Otherwise, we have to go for the another one. Next, please. Okay, yes. First question we have to arise that is molecule linear or non-linear? If it is linear, then C infinite V or D infinite H point group may be present. Now, in that case, if plane is perpendicular to the main principal axis, then point group is D infinite H. And if sigma v is present, it means if the plane is parallel to the main principal axis, then sigma v is present. So point group is C infinite V. Next one, please. Yes, these are the linear molecules: nitrogen, oxygen, hydrogen, carbon monoxide, hydrogen cyanide gas, HI molecule. These are the examples of the linear molecules. Now, according to the chart, first of all, we have to make a questions that is molecule linear or non-linear? So linear. If molecule is linear, then C infinite V or D infinite H point groups are present. Now in this case, in case of the nitrogen, oxygen and hydrogen, the planes are perpendicular to the main principal axis, so sigma h is present. It means point groups can be assigned as a D infinite h. In case of the carbon monoxide as well as HCN, the main principal axis is parallel to main principal plane is parallel to main principal axis, so point group can be assigned as a C infinite. So, dear students, we have to remember that first of all, first question we have to arise that is molecule linear or non-linear? If linear, then point group can be assigned as a D infinite H or C infinite V. Okay, then D infinite H, it means if plane is perpendicular to the main principal axis, then point group can be assigned as a D infinite H. And if plane is parallel to main principal axis, then point group can be assigned as a C infinite V. Next, please. Yes, this is another molecule, and the name of this molecule is a carbon dioxide molecule. Carbon dioxide is a linear molecule, and in carbon dioxide, the main principal axis is perpendicular to the main principal axis. The plane is perpendicular to the main principal axis. It means D infinite H point groups may be present. Okay. So we have to assign a d infinite H point group. Okay, if molecule is linear, then we have to assign 2 point groups C infinite V or D infinite H. Okay, if sigma V is present, then C infinite V point group, and sigma H is present, then point group can be assigned as a D infinite H. Next one. This is hydrochloric acid molecule. In case of the hydrochloric acid molecule, the plane is parallel to main principal axis, so we can assign a C infinite V point group to the hydrochloric acid molecule. So, dear students, we have to remember that if molecule is linear and sigma V is present, then C infinite V point group can be assigned. Next one. Yes, if non-linear, if linear, then C infinite V, D infinite H point groups can be assigned. But molecule is non-linear, and then we have to go for the next question, that any multiple harder axes are present. Now, what is the meaning of multiple? It means 3C3 is the minimum criteria to be multiple higher order axis. Okay, in case of methane and SF6 molecules, okay, they consist 3C3s, 4C3s. Yes, so TD or OH point group can be assigned to that molecules. Next one. So first molecule. Yes, next please. Yes, first molecule is the CH4. In case of methane molecule, symmetry elements are E4C3. Okay, 4C3 means 4 is the multiple and 3 is the higher order. It means multiple hard order axes are present in the methane molecule. And we know that sigma D is present in the methane molecules. So we have to make a questions that any multiple hard order axes are present. Yes, then IN, IH, TD or OH point group may be present. But in case of the methane molecule, sigma D is present. It means point group can be assigned as a uh, TD can be assigned as a point group to the methane molecules. And we know that the shape of this methane molecule is tetrahedral. Next molecule is the SF6 molecule. We know that the shape of this molecule is octahedral. So this molecule consists E C6. C6 is perpendicular to 6C2. C4 is the main principal axis, and 3C4 as a multiple harder axis are present, and sigma H is present. So in this case, the shape of this molecule is octahedral and sigma H is present. It means point group can be assigned as a sigma, as a OH. So point group of the SF6 molecule is OH. Next one. Yes. First questions, we already discussed that molecule is a linear and non-linear. Second question, multiple harder axis of symmetry. And now third questions, any proper improper axis are present in the molecule. If yes, then we have to go for the another option. But if no, then only C1, CS, and CI point groups may be present. Next one, please. Now, in that case, first molecule is bromochlorobromoiodomethane. Okay, we know that shape of methane is a tetrahedral, and its derivatives are also a tetrahedral. So, in this molecule, there is no proper axis. It means proper axis of symmetry is absent in this molecule. So, in this case, only symmetry element is only identity. So we can assign a point group to this molecule is C1. Next one, please. Another molecule is hypochlorous acid. We know that This is planar molecule, but there is no any proper axis of symmetry is present in this hypochlorous acid. It means point groups may be C1, Ci, or Cs, but this molecule is a planar, so point group can be assigned as a Cs. Next one, yes, this is trans 1,2 dibromo 1,2 dichloroethane. Okay, now in this molecule there is no proper axis of symmetry, or proper axis of symmetry is absent in this molecule. This is not a planar molecule, but I is present, that is center of symmetry is present in this molecule. So we can assign Ci is the point group to the trans dichloro 1,2 dibromo dichloroethane. Next one, please. Okay, so first questions to find out the or to assign the point group to the molecules. We already discussed that is molecule linear or non-linear. Any multiple order axes are present. Then any proper improper axis of any proper axis. If proper axes are present, then we have to make a questions that C2 is perpendicular to n C2s, yes and no. According to that, we have to go for the CNV, CNV, CNH, CND, and CN. And if Cn is perpendicular to NC2, in that case, we have to go for the DN, DNH, DND, and DNV symmetry, the point groups. Next one, please. So first molecule is the water molecule. Okay. In case of the water molecule, now we know that water molecule consists four symmetry elements: E, C2, sigma Vxz, and sigma Vyz. Now, in case of the water molecule is a non-linear. It means C infinite V, D infinite H point groups are absent. Multiple hard axes are also absent. It means TD, OH, and IH point groups may be absent. Then we have to make a questions: any proper improper? Yes, proper axis. Only one proper axis is present, that is Cn, or we can say C2. So two vertical planes are present. So point group can be assigned to the water molecule is C2V. Next one, please. Ammonia molecule. Ammonia molecule consists E, C3 plus C3 minus, sigma Va, sigma Vb, sigma Vc symmetry elements. Okay. So in this case, this molecule is a non-linear. It means C infinite V, D infinite H point groups are absent. Then we have to make equations that multiple harder axes are also absent, means yes, TD, OH point groups are absent. Then we have to make equations: any proper axis? Yes, C3 proper axis, C3 plus and C3 minus proper axis are present. So point group can be assigned as a C3V. Why C3V? Three vertical planes are present in the ammonia molecule. Next one, please. Bf3 molecule. This molecule consists identity C3 plus C3 minus, as well as C3 is perpendicular to 3 C2s and one horizontal plane, that is sigma H. So we have to go for the Cn is perpendicular to n C2s. Yes, C2 is perpendicular to 3 C2s. It means point group can be assigned as a D3H. Why? When sigma H is present in this molecule. So we can assign D3H point group to the Bf3 molecule. Next one, please. Benzene molecule. Okay. In case of the benzene molecule, one C3 is one main principal axis is C6, and C6 is perpendicular to 6 C2s and sigma H is present. Okay. So according to the our chart, molecule is non-linear. It means C infinite V, D infinite H point groups are absent. Then multiple harder axes are also absent. Multiple harder axes are also option. It means TDOH, IH point groups also option. Then any proper, yes, C6 is the main principal axis, and here C6 is perpendicular to 6 C2s, means we have to go for the DNH option. And order of axis in case of the benzene molecule is equal to 6. So we can assign D6H point group to the benzene molecule. Next one, please. This is special, sorry, B. Yes, this is PCl5 molecule. Next one, please. Next one, please. Yes, uh, this is trans dichloro hydrogen peroxide. This is planar molecule, and symmetry elements E sigma V C2. Just a minute, please. Uh, just previous slide, please. So here, this is uh, planar, or we can say trans hydrogen peroxide. Symmetry elements are identity C2 and sigma V. It means point group can be assigned to the trans hydrogen peroxide is C2V. Next molecule. Now this is Bf3. This is cis hydrogen peroxide. In this one, two verticals. Just previous slide, please. Okay, in this case, symmetry elements are E, C2, and sigma H. So point group can be assigned as a C2H. Next, please. This is hydrogen peroxide non-planar, or we can say cis hydrogen peroxide. So symmetry elements E, C2, and 2 sigma V. So point group can be assigned to this molecule is C2V. Next one. Alene molecule consists E, C2, and C2 is perpendicular to 2 C2s and sigma D. It means point group can be assigned to the alene molecule is D to D. Next one, please. This is staggered ethane. Okay. In case of staggered ethane, main principal axis is C3, and plane of symmetry is sigma D. Okay. And in case of the staggered ethane, C3 is perpendicular to 3 C2s. So we have to go for the DN option, DNH, DND, DNV, or DND option. So here n is equal to 5. So point group can be assigned to the staggered ethane is can be assigned to the staggered ethane D3D. Next one. Ethane, this is eclipse ethane. So main principal axis is C3, and C3 is perpendicular to 3 C2s, and sigma H is present. So point group is D3H. Next molecule. Ferrocene. Ferrocene consists two isomers. One is staggered ethane, and second one is the eclipse ethane. In case of the staggered ethane, symmetry elements are E, C5. C5 is perpendicular to 5 C2s and sigma H. Sigma D, it means point group can be assigned as a D5D. In case of the eclipse ethane, C5 is perpendicular to 5 C2s and sigma H is present, so point group is D5H. Next one, please. Transdichloroethylene. In case of the transdichloroethylene, E, C2, sigma H, and I is present. So point group can be assigned to this molecule is D2H. Next one, please. I think this is the end of our introduction part of our molecular symmetry. So dear students, we discuss up to this mark the general introduction regarding the molecular symmetry, and you already learned very well from the TYBSc semester 6. I think you listened very well to me, and I'm very very thankful to principals of KBS College, Dr. Poonam Ben Madam, Poonam Ben Chauhan Madam, as well as coordinator of this webinar series, Khushbu Ben Desai Madam, to give me opportunity, to give me a platform to share my views with the students. So once again, thank you very much, and also to dear students to listen me very carefully. Thank you very much.
Thank you, sir. Thank you very much. Dear students, our next session will be organized soon and we will let you know. Thank you, everyone. Thank you, all the participants.
Thank you, madam.